So there is a green reference sheet. And there's really just one formula today, guys, so we'll have it on our notes, so you can definitely do your homework. And Mrs. Hoffbauer, the sweet angel she is, she went ahead and circled the problems you're supposed to do on worksheet 2 for your homework tonight. So just make sure you complete all those. And that'll give you a good variety of the kind of questions we're going to ask you on the test. Now, sophomores and juniors, you guys will be taking a summative over all of this unit, but it's going to happen after the seniors leave us. So we're going to be learning sequences of series for the next, obviously the next 2 days, and then all next week, except next week is a hot mess, because like any given day, like half of you are gone for AP testing. So there's going to be a lot. We've strategically placed the lessons on the days where the least amount of kids are gone. And then the days where there's going to be a lot of you gone, those are like essentially going to be work days. Or answering questions on your work days. I don't know what that'll look like yet. What? I'm sorry? AP Lang Day is a big day. AP Chem. A Push. Seniors, there's not a lot of you, so I don't know. Do you have any APs? Not this semester. Do you have an AP? Stats, okay. It's like the 14th. No, I have the wrong date. It's not even close. It's some Thursday, isn't it? It's like the following week, I think. Oh, it's during your finals. That's not good. Okay, we'll figure that out. Don't worry. So the seniors last week, that is going to be devoted to your guys' post-test. Everybody's taking that post-test at the same time. For seniors, it is your final, essentially. But we're going to do that same thing we did last semester where we review on Monday, test part 1 on Tuesday. Review on Wednesday, test part 2 on Thursday. Which is your AP Stats day. So is it in the afternoon, though? It's just all math all day long. How fun. Seniors, if for some reason we get to the end of the semester and you are just so close to that next grade, we can figure out. I think we could offer you guys the option to take the other part of the final. Because your post-test only covers half of the material we've learned. The other part of the final covers everything else. So, hey, speaking of post-test, remember yesterday you guys had a worksheet that reviewed some trig stuff? You should start looking at that. You did? And it all came running back to you? Oh, okay. Well, maybe I'll see you in the morning or after school sometime. Maybe. All right. Yes. Yes. So then the week after post-test, so seniors say bye-bye on the 17th. Then we'll probably spend Monday reviewing this because it's been a while. Although we'll see most of it on the post-test, but there's some other things we haven't seen for a while. And then we'll take a summative over all this for everybody else on Tuesday. But then you have another final. Just basically, we're going to give you a test every day for the rest of your life, okay? You guys like testing. I heard about it. All right. So we are going to talk today about a very specific type of sequence or pattern, and it's going to be arithmetic. Okay, arithmetic sequences are, in little kids' terms, it's patterns where they add the same number every time. So just write down in your notes that they have a common difference. So we have a new notes packet. Difference. So as an example, you guys have seen these quite a bit. So like 1, 4, 7, 10. Is that a pattern to you? Can you describe the pattern in little kid terms for me? You're adding 3 every time. So what you guys just found for me is called the common difference, that you're adding 3 each time. So what about this guy? Let's see, 10, 8, 6, 4. What's the pattern there? So you can either say you're adding -2 or subtracting 2. So either way, that means the common difference is -2. So that's the kind of patterns that we're going to be working with today. We're going to be having a formula, which I don't know if it's on your notes, but you're going to want to write it down somewhere. The explicit formula for an arithmetic sequence is, I think it's coming up next. Yeah, right there. The one that we're going to be using is this one. A sub n equals a sub 1 plus d times n minus 1. So that version of the formula is on your green formula sheet. Let's kind of dissect what these mean now. So this term right here, they refer to this as the general term. However, sometimes it's not general at all. Sometimes it's very, very specific. So if they leave n as a variable, it means it's a recipe that you can be used for any number n. N is always an integer, by the way, because it represents which term you're talking about, the first term, the second term, the third term. So speaking of that, what do you suppose this represents? A sub 1 would be the first term. And then they have this value of d, which we just described as the common difference. And then when it says the variable n, if it's a general formula, n stays as a variable. However, if you're asking for a specific term, it's the numbered, I don't know how to say this, number of term, I guess. So we're going to see a question coming up where they ask you for the 52nd term in a sequence. So in that case, 52 would be n. All right, so we're going to be using the explicit formula quite a bit. We also have to learn something called a recursive formula, which sounds and looks a little scary, but personally I think it's easier than the explicit one. So when you have a recursive formula, they're going to give you a general form, and it looks like this. It looks like a sub n minus 1, and then plus d. The other thing they're going to have to tell you on a recursive formula, they're going to have to give you a head start on like where to start the formula itself, or the sequence itself. So they're going to tell you a sub 1 equals, and then some sort of a number. So this is the recursive formula, but then they have to tell you the first term in the sequence to get it going. Here's why. Anyone want to take a stab at what this means? It's kind of a weird notation, and I think notation's actually what trips kids up the most in this unit. If I say a sub n minus 1, that means the previous term. So a recursive formula is going to have a starting point, and then it's going to say take the previous term and then add a common difference every time. So you just keep working off your previous term, which is essentially what you guys do when you're small children, right? If we back up to those first couple examples I gave you guys, quickly you figured out the pattern. You're like, oh, I'm just supposed to add 3 every time. But then the next thing your little kid teacher would say is continue the pattern, right? So how do you get the next term? Well, you work off the previous term. You say 10, and then I add 3 more. So I got 13, and then I add 3 more. Little kids don't bust out their algebraic skills and write a formula. That's not how little kids work. So I almost think of recursive formula as like little kid style. The notation doesn't look little kid, but it's definitely a little kid thought process. All right, so here we have to determine if it's arithmetic to begin with, and if it is, tell me the common difference. So think about your hops here. How are we getting from one term to the other? We're subtracting 6, and it's happening from every term to every term, all the way through the ones that they provided me at least. So let's say yes, there's definitely a common, yes, it is arithmetic, because the common difference is a -6. Now, if you have a tough time finding common differences for some reason, like there's a challenging one coming up, what you can do is you can take 2 consecutive terms and subtract them. So like, for instance, you could take the second term and subtract the first term from it. That would be a mathematical formula for how to find the common difference. So the next one, well, of course, they throw fractions at me. So I can only really compare fractions if they have the same denominator. These are all good, but let's change the 3 to a 9/3. And now I'm wondering if you can see any sort of a pattern hopping from term to term to term. Aren't we adding 5/3 each time? Adding 5/3, adding 5/3. And again, if you had a hard time seeing that, so yes, it is arithmetic, and we're adding 5/3. If you had a hard time seeing it, you could use that little formula where you took 2 consecutive terms and you subtracted them. Make sure you subtract the second one minus the first one in that order. All right, so number 6. Let's look at the patterns. Here we're subtracting 1, and then over here we're subtracting 4. So right away I can say no, this is not arithmetic, because there's not a common difference to hop from every single consecutive term. There's probably a pattern, but that's not what they're asking me. They're saying, is it an arithmetic pattern? So no. And since the answer is no, you can't find a common difference, so move on. So these next few, they went ahead and said, these are arithmetic. So find the common difference, and then Find the next 3 terms in the sequence. So basically this is a little kid question. We're going to do, let's do the harder one. The fraction one. I need to compare them all. They're all, some of them are fractions, so let's make them all fractions. Let's change -2 to thirds. So how about -6 thirds? And then similarly over here, -4, let's change that to -12 thirds. So they already told me it was arithmetic. Can you find the common difference? They're subtracting 2 thirds. Yep, every hop. So if you continue on subtracting 2 thirds, that'll get you to -14 thirds. And then 2 more, -16 thirds. And then for that last one, it's -18 thirds, but I would expect PreCalc to reduce that to a -6. That says -6 if you can't read it. So that's little kid stuff. Let's do big kid stuff. Find the common difference. All right. Have you found it? How are we hopping? We are subtracting 8, I heard. Thank you. And then it says find the 52nd term. What would be a bad way to do this question? Write out 52 terms. Some of you were thinking of doing that. You're like, oh, never mind. I mean, that's just a big waste of time is what it is. And with me, like, then I'd have to go count 52 things, and then I'd probably lose count, and then I'd count them again. So it'd really be a waste of time. So let's come up with a better way, guys. Let's anticipate the math with a little bit of algebra. So your first term, which is, what is our first term in the sequence? 3. And then we do a bunch of these adding -8 jumps, right? Blah, 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 blah. Happens a whole bunch of times. And then we get out to the 52nd term. And they want to know what this number is. Well, how many times did you do those hop, 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 hop to get to this term? How many steps did I take to go from the first term to the 52nd term? 51 steps. Because we're already on the first step, okay? So 51 steps to get to the 52nd step. So if I think about that mathematically, that means you start with the number 3, and then our steps are subtracting 8 every time. So we're going to subtract 8, and you guys told me we're going to do that 51 times. Well, that's a lot quicker than writing out 52 terms, so. Yes, I should be able to do that in my head, but no, I'm not. Is it -405? Go with it. Are we okay with that? All right, so same thing here on number 10. You've got your first term of -4, so start at -4. And then what's our steps here? What are we doing every time? Did I screw up something? Oh. Did you use a subtraction sign or a negative sign? You can edit. All right, what's our step here, guys, for our common difference? We're adding 20 every time. So if we add 20, but it's the same problem. So how many times, how many steps to get from 1 to 52 is 51 steps. So on my calculator, I have this written down, 1016. Did you get it to work out yet? Oh, okay. Okay. So these next couple, they actually want the explicit formula from you. So the explicit formula that they're referring to is this guy, which your book, I think, has another version of this formula where they manipulate it a little bit. I just don't feel like it's worth you memorizing that formula because it's not very useful. So since this one is on our formula sheet, we'll just keep giving this one. In order to come up with this explicit formula, you have to figure out the first term, and then you have to figure out the common difference. Well, I think the first term's like staring at you. Do you see it? This guy, right? So a sub 1 means the first term. Did I skip a bunch of questions? Not yet? Yes? I feel like I did. Maybe they're coming up. All right. Common difference. Well, they don't have common denominators right now, so if you had to like do this in your head, you'd want to compare these out of 10. So I would change that to a 24 over 10. And now do you see the common difference? Now be careful. It is 15 out of 10, but pre-calc, I'd expect you to reduce that for me. So instead of 15 over 10, would you call that 3 halves? So your common difference is adding 3 halves every time. Your first term is 9/10. So as far as explicit formula goes, I'm going to leave the title of it in what we call general form, a sub n equals the first term, 9/10. And then we're adding 3 halves times the quantity n minus 1. Now, I'm going to warn you, the key I posted is the computer-generated answer key. So do you think they left their answer in this format? No, they distributed the 3 halves and then they collected their fractions together on the constants. Me personally, I'm too lazy to do that. So that's a pretty easy question for you guys on your homework. If you don't mind just believing in yourself that you got it right, then you can just stop there. But if you're worried, oh, I think I messed it up, then you're going to have to distribute in order to match the answer that's on the answer key, okay? All right, same idea for number 12. I'm going to move on. I'm getting bored. Here we go. So this next one, this has an explicit formula, and it's like how the computer does it. It went ahead and simplified it so that it doesn't have the n minus 1 in its own quantity. So it's a little harder for kids to understand like what's going on in this version of the formula because it's hard for you to pull the pieces apart. So I'm actually going to answer this question kind of backwards on this first one so we can see what's going on. They want me to figure out the common difference, and they also want me to come up with the first 4 terms. So the first 4 terms in sequence notation are called a sub 1, a sub 2, a sub 3, and a sub 4. So when I'm asking you to find the first term, you go to your recipe, and what do you suppose you do? What does the n equal? 1. So you just plug in a 1 for n. So 197 minus 200 times 1, your answer comes out to a -3. So the first term in this sequence would be a -3. Now, if you knew the common difference already, you could just continue on and move forward in your pattern. However, if you weren't sure what the common difference was, go find the second term by literally plugging in n equals 2. And you should get -203. Okay, guys, I think I know the common difference. What's your common difference? Yes, a -200. Where in that formula do you see that common difference? It's the coefficient of the variable, okay? So remember, at some point in the math, whoever came up with this formula, they started with this formula, but then they went ahead and they distributed the common difference and then they added some constants together and they ended up getting to this formula eventually. Obviously this formula doesn't tell you about the first term, so you got to calculate it. This formula, when it's all separated, is easy to pull things apart. Okay. Now that we know the common difference, I don't think we need to keep using the formula anymore, just keep subtracting 200. So -403 and -603. Try to really utilize the notation. So if it says like you have the fourth term, call it a sub 4. All right, what else do they want? Oh, that was it. All right, moving along. So this next one's similar. They want you to come up with the first term, second term, third term, fourth term. But now that you're wise to how the formula works, can anyone tell me what the common difference is going to be? Yeah, 2.3. You're going to be adding 2.3 every time. So that doesn't help you get the sequence started, though. You are going to have to go calculate the first term. It's not that hard, though. You just plug in a 1. So if you plug in a 1 right there for n, you get 14.4. And then now that you know the common difference, you can just continue on and use the pattern, unless you wanted to program something. We're going to talk later about how we can program our calculator to do sequences and series eventually for us. For now, just think of them as little kid questions. They're pretty easy. So if we continue on, we keep adding 2.3, we get 16.7, 19, and 21.3. Did I do all my adding right? Yeah. So here, they're going to give you an example of what's called a recursive formula. And as long as you know how to translate them, they're actually pretty nice. So this is the formula itself, this guy right here. But someone remind me, what does this term mean when it says a sub n minus 1? It's the previous term, yeah. So whatever the last term was you got, if you want to move forward, we're going to have to do what to that previous term? What does it say to do? Add 2. So that plus 2 at the end of the recursive formula, that is your common difference. So underneath your recursive formula, they go ahead and give you a starting point. It says the first term of your sequence is negative 21. So given the recursive formula, find the common difference, already did that, and then find the first 4 terms. So a sub 1, a sub 2, a sub 3, a sub 4. They already told me the first term was negative 21. And then the difference pattern says to move on, you take the previous term and you add 2 to it. So adding 2 to this, you get negative 19, negative 17, and negative 15. So I really like recursive formulas. I feel like there's less work to them. All right, similar here, guys. We have a recursive formula where it says take the previous term and you're going to do what to move ahead in the formula? Subtract 1.1. So first term is negative 2.6. So to move ahead in the pattern, you're going to subtract 1.1. So negative 3.7 for my second term. The next guy is negative 4.8. And then the fourth term would be negative 5.9. Very unsure of my subtraction today. It's one of those days. All right. So far, so good? Nothing too bad? So now if I give you a sequence list, can you come up with the recursive formula? So there's 2 parts to the recursive formula. Remember, there's the formula itself, and then there's what the first term is. Well, I can get the first term one done really fast. Who's the first term? Yeah, 16. Okay, so for the formula, you always start with the previous term. How do I write the previous term for sequence notation? A sub n minus 1. Good. So the previous term, and now you got to figure out the common difference. What are they doing to move from term to term to term? They're subtracting 9. So previous term and then minus 9 would be how you move. Ta-da! Done. So this is the formula, and this is the first term to get going on the formula. So you need both parts. All right, the next one's a fraction. So of course I don't like that they're half fractions, half not. I'm going to change them all back to fractions with denominators of 2. So call this guy 2 over 2 and call this guy 0 over 2. So now talk to me about my recursive formula. So I know it's going to start with the previous term, so a sub n minus 1. But then has anybody caught on to the common difference? We're subtracting 1/2. And then I got to tell my reader where they should start their sequence. And they should start it at 3/2. So this is the sequence formula. And this is the first term to start it off. Oh, fun. Okay, so they're going to give us an explicit, and then we got to go find the recursive. All right. So if I think about what I need in order to write a recursive, I know it starts with, quote, the previous term, so a sub n minus 1. And then the next thing I have to write down is the common difference. Well, do you remember which number we can kind of pull out of this that'll create the common that is the common difference? It's that coefficient. So the common difference is a 30. So I'm going to just kind of sneak that on there. Now the thing we don't have, and we are going to have to find it, is the first term. So at some point, I need you to calculate the first term. Well, that's not that hard, guys. We're just going to plug in a 1 right there. So negative 26 plus 30 times 1, better known as 4. So when they have that simplified looking explicit formula, you have to do a teensy amount of work to find the first term. but everything else is sitting there for you. The other way to do that question is what some kids do is they just start listing out the terms. So like they plug in a 1 and a 2 and a 3, and then they can see all the pieces they need. So like here, if they plug in a 1, they plug in a 1 right there, they get a negative 27. If they plug in a 2, they get a, whoops, pen, come on. They get a negative 25. And if they go one more time, they get a negative 23. And then because of the way the sequence works, like if you're a good pattern identifier, you can say like, oh, well, clearly the first term is negative 27 and my common difference is plus 2. So if that's the way your brain works, if you'd rather see the sequence mapped out, then go ahead and map out the sequence. No problem. And that kind of goes for everything in today's lesson. Some kids are really good at like conceptualizing patterns and how they work and how you hop from one term to the other. And some of us aren't. And those of us who aren't good at conceptualizing have to really rely on the formulas to get it right. And I don't mind which way you get the answer right. I just want you to practice it that way, okay? This one, it's really not too bad. Find the term that they want and then come back and give me a formula. So, all right. I don't know about you, but wouldn't it be easier just to find the formula and then go find the term? For those of us who aren't good at conceptualizing, I think that might be brilliant. So let's just go ahead and find the formula. And because I'm lazy, I'm going to leave my formula in the non-simplified version. So the first term of our sequence, clearly negative 33. And then the non-simplified formula says plus the common difference. Well, how you hopping here, guys? What are we doing? We're adding 8. So plus 8. And then it's times the quantity n minus 1. So as far as formulas go, I'm great if you guys just leave it right there. Did you guys remember that one question we did with the 52nd term? And I asked you all, where's it at? Yeah, advanced. Yeah, there we go. I asked you how many steps were between the first and the 52nd term, and the answer was 51 steps. Look at your formula, guys. That thing that we had to do mentally is part of the formula. Do you see it? That's right here. It's n minus 1 steps to go from step whatever to step whatever. Like it's already in the formula. You don't have to think about it, okay? So to find the 30th term, and this is the notation I want you guys to use, because n is no longer going to be the general term, it's literally the 30th term, you're going to call it a sub 30, and then you're going to use your formula. So negative 33 plus 8, and then because I want the 30th term, in the formula, it says 30 minus 1, but that's why it's 29, right? We're only adding 29 steps to get to that term. So this comes out to something. What was it? 199? Okay. So the 30th term is 199. Cool, cool. All right, I'm going to move on. That's getting boring. But this isn't. This is exciting. You ready for this one? Holy random facts, Batman. I am giving you the 16th and 34th term. Well, that's helpful. And then I want the 27th term. So my conceptualizers are like, oh, I got this. Like, you guys can figure it out. You know exactly how many steps you're moving. Maybe you even literally map it out on your paper. That's cool. I'm going to do something kind of similar. I'm going to say, all right, we're at the 16th term. And it is the number 338. And then there's a bunch of stuff in the middle here. And then we get to the 34th term, and that is the number 698. And I think I need the secret to this pattern. I need to figure out how the hops work. So I went from 338 up to 698. So mathematically speaking, if I need to find the common difference, what I'm going to do is first I'm going to find the difference. So 698 minus 338 divided by, now this is going to confuse some kids because it's a little confusing because of the n minus 1 part of the formula. If you're at the 16th term and all the way up to the 34th term and I ask you about how many steps you took, the answer to that question is that you took 18 steps. Okay? On that other question we were talking about previous to this one, you were already on the first term. It's going to get confusing, guys, so if you just can believe me that it's 18 steps for now, that'd be fine. So you're going to have to divide that by 18 because that's how many times they added the common difference to get to there, to there, to there, to there. And what does this come out to? Well, I think that's 360 over 18, so 20. Very good. So the common difference is a positive 20. So I know the common difference, and I'm supposed to find the 27th term. So you need to pick a starting spot. I don't think I want to go back to the beginning of this formula, guys. It doesn't ask me to find the formula, so let's not do that. Let's say I'm going to start at the 16th term. Okay, so starting at the 16th term, you're at 338. And then every time we make a step, you're going to move plus 20. But my question to y'all is, how many steps did we take to go from the 16th term up to the 27th term? 11. Okay, so you can just call it 11 steps. Or what else could we have done was the weird n-1 thing. It's going to get confusing, right, guys? Because you're like, wait a minute, is it n-1, n+1, what's happening? Just think of them as steps, okay? To go from the 16th to the 27th is 11 steps, yes. What does that come out to? 558, thank you. So there's some homework questions that are going to be just like that. I'm going to give you 2 random factoids about the sequence. You got to figure out the common difference by literally finding, you know, the big difference divided by how many steps it took. And then move forward or backward sometimes in that sequence based on that common difference. So let's try another one of those because I think those are kind of nasty. So we've got the 20th term, very random, and the 32nd term. So to find the common difference, I'm going to need you guys to subtract those, but go biggest, like the further out one first. So negative 3062 minus negative 1862. And then careful here, guys. You're at 20th up to the 32nd. So it's 12 steps. I'm sure this comes out lovely. The common difference for generally the ones we assign you are pretty nice. So if you get something weird, then maybe something's up. What is this one? Negative 100? Cool. So every time they move from term to term to term, they're subtracting 100. So I need you to get to the 36th term. So it's up to you guys where you start. It does not matter. Neither one's easier. Which one do you want to start at? The 20th or the 32nd? 32nd. All right, so start at the 32nd term, which is negative 3062. And then be careful here, guys. Remember, your common difference is negative 100, so you're going to move forward 4 steps. So I'm just going to say minus 100 and then 4 steps. You get negative 3462? Awesome. Okay. Cool, cool. All right, what else we got? They saved the best for last. Here we go at number 25. Given 2 terms, find the explicit formula. So this time, it's not just some random thing in the middle of my sequence. I do need the whole formula, so I'm going to have the common difference, obviously. But I'm also at some point in my math going to have to come back and find the first term. So, I'm going to show you a couple of ways to find the first term, and you can decide which one works better for you. Neither one's easier than the other, so it's up to you. Let's hurry up and find the common difference, though. So 7019 minus 3819, and then please divide that by 16 steps. Is that 200? Cool. Okay. So regardless of your method of choice, you have to find the common difference this way. Now, this is called the conceptualizing method. To find the first term, it's what we had been doing in the previous questions. If you start here at 3819, I need you to back up all the way to the first term. So instead of adding 200, because we're going backwards in the sequence, we're going to have to subtract 200. How many times? Because you're at 20 right now, you need to get back to a 1. 19 times, okay. So this is how you can find the first term. Totally great way to do it. This is the way I do it. So of course it's great, right? No, not really. Is it 19? Awesome. So you have the first term. You have the common difference. That means you have the formula. So the explicit formula is first term, so 19. And then remember, your common difference is technically a positive one. We were just going backwards. That's why it was negative in the formula. But now it's back to positive 200. And then keep it general times n minus 1. So using that explicit formula, I could find you any term you want. You want the 158th term? I got it. After I calculate it, because I don't have it. All right, so let me do, they're both kind of the same question. I'm going to redo that question using the formula, because it's already half done. So let's pretend I already found the common difference, right, of, was it positive 100? I forgot. 200, okay. Oh yeah, it's right there, duh. So another way to find the first term is to literally use your formula. So what I'm referring to is like the general one that has nothing plugged in. Remember this guy with nothing plugged in? Because we have some random facts about our sequence, right? They originally gave me, I forgot, the 20th term and the 36th term. So it doesn't matter. Someone take a vote. You want the 20th term or the 36th term? 20th. Sounds good. Thanks. All right. So what we're going to do is we know the common difference, and we're going to use the clue that says the 20th term is 3891. No, 19. Dyslexia. Here's what you do. You take the 3819 and you put it right here. Because instead of keeping it as any old general term, I'm saying it is that term, the 3819. I do not know what the first term is, but I do know that the common difference was a plus 200. And because we didn't use a general term anymore, we literally used a specific term. What term was that again? The 20th term. So instead of saying n minus 1, I'm going to put a 20 minus 1 right there to indicate it was the 20th term. Now, do you see that a sub 1 is the only unknown thing in that equation now? Now you can solve for a sub 1 that way. So 3819 minus, oh look, it's the same exact math we did up there. Okay, so my friends who are really having a hard time conceptualizing steps and jumps and things, you're going to have to come back and use the formula. You're going to get to the same mathematical setup at some point. But my honest opinion is if you can conceptualize it, it becomes much easier. Your homework will go very fast. Okay, speaking of homework. Turn the page. Ms. Hoffbauer, sweet soul, circled all of them for you. Okay, I posted the key. Like I said, it is a computer-generated key. The explicit formulas are all going to be simplified, so sorry about that. If you just trust that you did it right, you can, if their common difference matches, you're good, I think. So just move on from there. All right, guys, good luck. Everyone's doing their homework tonight. Yeah, no more lectures from Abruzzo.